Right now, 4 kilometers beneath the ocean's surface, there's a treasure trove worth more than all the gold ever mined in human history. And here's the disturbing part. We have no idea what we're about to destroy to get it. China just deployed its third deep-sea mining vessel. Norway opened 108,000 square miles of its seabed to exploration in January 2025. The metals company has a robot ready to scrape an area the size of Belgium clean by late 2026. The race is already happening, and most people have no clue what's at stake. This isn't about finding new resources. It's about who controls the future of energy, technology, and quite literally who gets to decide what the green revolution looks like. Because without these minerals, every electric vehicle, every wind turbine, every solar battery becomes impossible to build at scale. So why are environmental groups comparing this to strip mining the Amazon, but underwater? And why are major nations suddenly treating the deep ocean floor like it's their backyard? Let me take you somewhere most humans will never see. Imagine you're standing at the edge of the Grand Canyon, but instead of looking down, you're looking at complete darkness. Now multiply that depth by 3. You're in the Clarion-Clipperton Zone, a massive stretch of ocean floor between Hawaii and Mexico that's about to become the most contested real estate on Earth. The ocean floor here looks like someone scattered billions of black potatoes across an endless plain. These aren't potatoes, obviously. They're polymetallic nodules, and each one took roughly 4 million years to form. Think about that for a second. 4 million years. The entire span of human evolution twice over just to create one rock the size of your fist. But here's what makes them valuable. Crack one open and you'll find nickel, cobalt, manganese, and copper all fused together in concentrations that make traditional mining operations look pathetic by comparison. We're talking about 21 billion tons of these nodules just sitting there in this one zone. To put that in perspective, that's more nickel than exists in all known land deposits combined. Gerard Barron, CEO of the metals company, made a statement in 2024 that sent shakewaves through the industry. He said, "We can produce enough battery metals from 1 million square kilometers of seafloor to power 280 million electric vehicles without touching a single rainforest or displacing a single community." Sounds perfect, right? The ocean floor is lifeless anyway, isn't it? That's exactly what companies want you to think. But Dr. Diva Amon, a marine biologist who's actually been down there, describes something completely different. She talks about glass sponges that take thousands of years to grow, about species we've never seen before living in complete darkness, feeding on the minerals leaching from these very nodules. But let's stay focused on why nations are suddenly treating this like a military operation. Every government on Earth has made the same promise: carbon neutrality by 2050. Electric vehicles, renewable energy, grid-scale batteries. The entire global economy is betting on a technological transition that requires one critical ingredient we're running desperately short of: cobalt. The Democratic Republic of Congo produces 70% of the world's cobalt right now. And if you've followed any news about Congolese mining, you know exactly why that's a problem. Child labor, environmental devastation, political instability, and one nation holding the entire green energy transition hostage. China figured this out before anyone else. Between 2010 and 2020, Chinese companies quietly bought controlling stakes in 15 of the 19 cobalt-producing mines in the Congo. They didn't announce it, they just did it. And now, as of 2024, China controls approximately 80% of the world's cobalt refining capacity. Here's where it gets interesting. A single deep-sea nodule contains about 0.25% cobalt. That doesn't sound like much until you realize that land-based cobalt ore averages 0.15%. The ocean floor is literally more concentrated than what we're mining on land. Tesla alone needs 8,000 tons of cobalt per year just for current production.
Multiply that by every other EV manufacturer, every grid battery project, every power tool, every laptop, and you start to see why the metals company's stock jumped 47% in February 2025 when they announced their harvesting timeline. But there's something nobody's talking about yet, and it's going to change everything. For decades, deep-sea mining was science fiction. The pressure 4 kilometers down is equivalent to having 3 SUVs stacked on every square inch of your body. Traditional equipment just crumpled, robots failed, communication cut out. It was technically possible, but economically insane. Then Nautilus Minerals went bankrupt in 2019, and everyone assumed deep-sea mining was dead. They were wrong. What changed wasn't desire, it was artificial intelligence. In March 2024, Belgium-based Global Sea Minerals Resources tested a robot called Pitanya 3 that can navigate the ocean floor using machine learning to identify and collect only high-grade nodules while avoiding areas with visible marine life. The success rate was 94%. Here's the part that should terrify you. The robot doesn't need human oversight. It maps terrain, plans routes, avoids obstacles, and operates continuously for 72-hour cycles before surfacing. The metals company has already built 4 of these machines, and they're planning to deploy 12 more by October 2026. Japan went a different route. In January 2025, they successfully tested a vacuum system that sucks nodules directly into a riser pipe without the tracked collector vehicles that everyone else is using. It's 40% more efficient and creates less sediment plume. China saw the results and immediately announced a $2.3 billion investment into similar technology. Norway's approach is even more aggressive. In their newly opened seabed zones along the Arctic Circle, they're not mining nodules, they're targeting polymetallic sulfides near hydrothermal vents that contain rare earth elements critical for military technology. We're talking about scandium, yttrium, elements most people have never heard of, but that are essential for advanced radar systems, missile guidance, and satellite technology. This isn't just about batteries anymore. This is about technological supremacy. And that's exactly when things start to look less like commerce and more like conquest. The International Seabed Authority is supposed to regulate all of this. It's a UN body based in Jamaica with 167 member states and one very simple job: decide who gets to mine the ocean floor and under what conditions. In July 2025, they failed to reach a consensus on final regulations. Not because of environmental concerns, because China, Russia, and Norway wanted weaker restrictions, while Pacific Island nations wanted a complete moratorium. So what happens when there are no agreed-upon rules? Countries start claiming territory that belongs to no one. China has already surveyed 72,000 square kilometers in the Clarion-Clipperton Zone under exploration contracts that technically don't allow commercial mining, but somehow involve industrial-scale equipment being positioned right now. Russia is surveying the Arctic mid-ocean ridge. India has claims in the Indian Ocean. The United States was completely absent from this conversation until the Biden administration suddenly announced in late 2024 that domestic seabed mining was a national security priority. Lockheed Martin, through its UK subsidiary UK Seabed Resources, immediately activated contracts they'd held dormant since 2015. Dr. Pradeep Singh, a researcher at the International Union for Conservation of Nature, said something in a 2025 interview that stuck with me. He said, "We're watching the colonization of the last frontier, and it's happening with the exact same logic that carved up Africa in the 1880s. First come the surveyors, then come the extraction companies, and finally comes the military to protect economic interests." And he's not exaggerating. France deployed naval assets to protect its claimed zones near French Polynesia in March 2025. The UK has HMS Protector conducting scientific missions that just happen to be in the exact coordinates where British companies plan to mine. This is where it stops being theoretical and starts getting dangerous. Imagine you've invested $800 million in robotic mining equipment sitting on the ocean floor 4 kilometers down. You have no military, no way to defend it, and you're operating in international waters where no laws clearly apply. Now, imagine a competitor nation decides to send their own robots to sabotage your equipment. Who do you call? What laws were broken? What recourse do you have? This is the nightmare scenario security analysts started warning about in early 2025. These aren't hypothetical concerns. In February 2025, the metals company reported unexplained equipment malfunctions in their test zone. Nothing was proven, but the company's chief of operations mentioned foreign interference in an earnings call before the legal team shut him down. China's strategy is particularly sophisticated. Rather than direct conflict, they're executing what military strategists call gray zone operations. This means using civilian research vessels that just happen to cross through competitor mining zones, deploying scientific equipment that interferes with acoustic mapping, and claiming
overlapping survey rights that force international arbitration that takes years to resolve. By the time legal disputes are settled, the mining has already happened. Norway's opening of Arctic seabeds has a darker layer to it. Those deposits aren't just near their territory, they're adjacent to contested areas where Russian and NATO interests overlap. If Norway deploys mining operations, they'll need NATO naval protection. If Russia objects and sends submarines to monitor the activity, suddenly you have military forces from nuclear powers facing each other in freezing Arctic waters over polymetallic nodules. Does that sound like a stable situation? The Biden administration's 2025 National Defense Authorization Act quietly included $470 million for underwater domain awareness and seabed resource protection capabilities. That's military budget language for we're preparing to defend mining operations with force if necessary. But here's the question nobody wants to answer. What happens to the ocean itself when this industrial war begins? The metals company's marketing is brilliant. Their entire pitch is framed as environmental salvation. No deforestation, no displaced indigenous communities, no child labor. Just robots quietly collecting rocks from a barren ocean floor. Dr. Ammon, who I mentioned earlier, spent 3 weeks in the Clarion-Clipperton Zone in 2023. She documented over 70 species that were completely unknown to science, living exclusively in and around these nodule fields. When I say exclusively, I mean these species exist nowhere else on Earth. Remove the nodules, and these organisms have no habitat. The sediment plumes are the other problem. When these collectors scrape the ocean floor, they create clouds of disturbed sediment that can drift for dozens of kilometers before settling. MIT researchers modeled this in 2024 and found that at industrial scale, sediment plumes from the single mining zone could affect an area 3 times the size of the actual mining footprint. But there's a more fundamental question here. The deep ocean produces half the oxygen we breathe through microbial processes we barely understand. It regulates global climate by absorbing carbon dioxide. It's the largest habitat on Earth, covering 65% of the planet's surface, and we've explored less than 5% of it. So what happens if we make a mistake? What if there's some critical ecosystem function happening in these nodule fields that we don't discover after we've strip mined millions of square kilometers? You can't put the nodules back. They took 4 million years to form. This is where the conversation gets really uncomfortable, because there's a scenario where we don't need any of this. Sodium-ion batteries. If you haven't heard that term yet, pay attention. In 2024, Chinese company CATL began mass production of sodium-ion batteries that contain 0 cobalt, 0 nickel, and 0 lithium. They're cheaper, safer, and have slightly lower energy density than current lithium-ion batteries, but they're improving rapidly. BYD, the world's largest EV manufacturer, announced in January 2025 that 30% of their 2026 models would use sodium-ion technology.
If sodium-ion batteries become viable at scale, the entire economic justification for deep-sea mining collapses overnight. Then there's urban mining. The average smartphone contains more gold per ton than a typical gold ore deposit. Electronic waste represents an absolute massive reservoir of recoverable metals that we're currently just throwing away. Companies like Redwood Materials are already recovering 95% of the cobalt and nickel from recycled batteries. The European Union's Circular Economy Action Plan, updated in 2024, mandates that by 2030, 70% of battery materials must come from recycled sources. If that becomes global policy, demand for virgin materials drops dramatically. So here's the real question. Are we about to irreversibly damage the deep ocean for a resource we might not even need in 10 years? Because that's the insane part of this entire story. The technology to avoid deep-sea mining already exists. We could invest the billions going into submarine robots into circular economy infrastructure instead. We could fund sodium-ion research. We could build recycling facilities. But that requires coordination, regulation, and patience. And right now, the race to the ocean floor is driven by exactly the opposite impulses: competition, deregulation, and the absolute certainty that whoever gets there first will control the future. China isn't waiting for better alternatives. Norway isn't pausing for more research. The metals company has investors demanding returns. The deep ocean isn't just the last frontier. It might be the last place on Earth where we could still choose differently. But that choice has to happen now. Not in 2030 when the damage assessment reports come in. Not after the first major blue conflict. Right now. Because once those robots start scraping the ocean floor at industrial scale, there's no going back. And we'll finally have our answer to whether humanity learned anything from every previous gold rush in history. I'm guessing we already know how this ends.